So intervals are basically inequalities. We are not going to use equal signs. We're going to use symbols such as greater than or equal to, greater than, less than, or less than or equal to. And it just means that instead of one solution, you have an entire set of solutions, right? So where does your solution begin? Where is the possible like window of your solutions begin, and where does it end if we were to write them on a number line, right? And then we will be writing them in notation. So an interval is a part. So an interval notation is just how to write that part as just a pair of terms and either brackets or parentheses, okay? So an open interval uses parentheses to represent less than or greater than. So an open interval, which you're just mostly used to, we'll just call it this, right? The parentheses means it does not include or does not equal, right? Does not include or does not equal the number. A closed interval will use brackets, and that does equal the answer or does include. I want to say include, but we're going to see it as half of an equal sign, so maybe it's easier to say equal. It's up to you. Good? So parentheses means if it's less than, that means it's going to be a parentheses, a closed parentheses or a parentheses moving that way. And the arrow is going to go behind it in the less than direction, right? Or our only other option is greater than. Good. So an open interval means it does not equal. A closed interval, less than will include a bracket and it will include that number. And go to the left. Or if it's greater than or equal to, it will go to the right. Does equal or does include. Does not equal or does not include the term itself, right? In this case, they're all A or B. So the interval notation that uses a bracket, the number, a comma, the symbol infinity, and then close parentheses means X is greater than or equal to that number. Okay? Any questions? I think we've seen this before, right? If I had to graph that, obviously we're going to start at A, right? Greater than or equal to. So because of that equal to, it's a bracket and it's going in that direction. The bracket on your graph is the exact same as the bracket on your notation. Conversely, this one is also greater than, but it does not include A, right? There's no equal sign. So that is just going to be parentheses instead of a bracket. In other math classes, you might see the parentheses represented with open circles, right? And the brackets are colored in circles. So it could be something like that. And then parentheses look more like that. Infinity always uses parentheses. So if I was going to represent all real numbers, I would go from negative infinity to infinity, but there's no end to infinity, so it can't include infinity. So infinity and negative infinity always use parentheses, never brackets. We will never be equal to infinity or the end of infinity, including it. Good. All right, so here was including A going towards infinity. Here's including A, or no, sorry, not including A going towards infinity. Here's beginning at negative infinity and stopping at but including a. So this is from negative infinity to a including a, or x is less than or equal to a, right? So it includes the bracket, and then we're going in the less than direction. The bracket because of the equal sign, right? The next one, it's also less than, but it's not including, so that's just going to be parentheses. Good? Seeing the differences? Here, these are just linear inequalities, the first four, and then we have compound inequalities, which just means there's more than one. So there's more than one side to the inequality, right? A is less than x and x is less than b, or x is greater than a and x is less than b. So for that one, x is greater than, I need an a and I need a b. So x is greater than a, x is less than b. But it doesn't include either of them, right? Because there were no equal signs. You can just take that interval notation and write it on your graph between a and b. The next one, same terms, a and b. But it's a is less than or equal to x and x is less than or equal to b. So they're both brackets, just like the interval notation is written in brackets. And then finally, you can have some combination of the two. So this one looks like we still have a, we still have b, but x is greater than or equal to a, so a actually has a bracket, but it's just less than b, so b only has parentheses. You're taking that interval notation, copying it onto your graph. Anytime you see a bracket, you include the equal sign. If there's only parentheses, do not include an equal sign. Good. And obviously, should have started with this, but this is the direction of less than on the number line. And this is the direction of greater on the number line from whatever point we are beginning. That last one is x is greater than a, but less than or equal to b. So b has a bracket because of that equal sign, and then a has parentheses. If you're comfortable with the infinity symbol, I think an easy way to translate from interval notation to graph is just to look at that parenthesis, start that parenthesis at that number, end the parenthesis at that number, start the bracket at that number, end the bracket at that number. And then if you know that infinity means an arrow to the right and negative infinity means an arrow to the left, and that you're always reading from left to right like it's English. Good. So if we had x is greater than -5 and x is less than 5, right? Then we would just have something like this. And then I can take my interval notation right off my graph, parentheses, -5 to 5, not including 5 or -5. Good. Negative 5 is less than or equal to x, which is less than or equal to 5, is going to look like that same graph, but with brackets because of the equal sign. If I had x is less than 3, that does not have a bracket, or sorry, it does not have an equal sign, so it's not going to be a bracket. It's just going to be parentheses. And then how do I write this as interval notation? Remember, if you see an arrow going in the less than direction, it's going towards negative infinity. That arrow's going on forever. So we're going to say parentheses, negative infinity to 3, and then close the parentheses because it does not have an equal sign. Negative and positive infinity always get only parentheses, never a bracket. X is greater than or equal to 4. Here's 4. And because of that equal sign, there's going to be a bracket. It's going in the greater than direction. So it's going to look like that. And then just maybe one more. Negative 3 is less than x, which is less than or equal to 5. So I need negative 3 and 5. It's greater than negative 3, but less than or equal to 5. Oh, sorry, I stopped doing interval notation. Bracket up here would be bracket 4 goes on forever, never ends, so infinity. Here we're starting with negative 3, but there's no equal sign, so we're just going to say parentheses negative 3 ends at 5, but includes 5 because of that equal sign. Any questions about how to write interval notation or how to graph an inequality? It's okay. All right, well, that's how to write it and how to graph it, but this is actually called solving, so let's start practicing. Nope, we're just gonna write some more, sorry. Got everyone's hopes up. All right, 4 is less than or equal to x, which is less than or equal to 7. Another way I like it if my variable is always on the left, so you can change 4 is less than or equal to x is greater than or equal to 4, if you like that. And x is less than or equal to 7. But you don't have to. So we have a 4 and we have a 7, right? X is greater than or equal to 4. Greater than is this direction, right? And it includes 4 because of that equal sign. So I'm going to write a bracket around 4 and I'm going to make my arrow go this way because that's the greater than direction. And x is less than or equal to 7 because of this equal sign. I'm going to put a bracket around 7 and it goes this direction. So we are including everything between 4 and 7. And we're including 4 and 7 because of those equal signs. So just write what you graph. From 4 to 7, inclusive. Put a bracket around 4 and 7. Good. Here we have negative 3 and 0. I like to write them down and really think about where negative 3 is and where 0 is to make sure that they're lined up with x between them. X is greater than negative 3. That means my parentheses is going this direction. X is less than 0. It is between negative 3 and 0 because it's greater than negative 3, but less than 0. For interval notation, I'm just going to write down what I graphed. I started at negative 3 with a parentheses, and I ended at 0 with the end of the parentheses. Here we have x is greater than 3, so I only need 3 on my number line. The greater than direction is that way, right? So I know I'm going this way, and there's no equal sign, so I just have parentheses. Parentheses 3, so I said write what you graph, but that's all I have, right? Except that this goes on forever. So if you see an arrow in the positive direction, that arrow is going on forever. Forever means infinity, right? Infinity only ever has parentheses. This one says x is less than or equal to 5. So less than is that direction, but it did say equal to. So because of that equal to, I need a bracket, just like because of these equal tos, I needed brackets. All the numbers less than 5 means it goes forever in the negative direction, right? So I know I end at 5, and there's a bracket around it. But the arrow to the left means negative infinity. Something that a lot of people get confused about is the difference between this and this. Or sorry, that was a positive 5. Doesn't really matter. You can never put negative infinity before your 5. You can never put positive infinity before your 3, for example, okay? It should always be from left to right on a number line, okay? So if I'm going from left to right on the number line, I'm always going to see negative infinity first. If I'm going from left to right on the number line, I'm always going to see infinity last, okay? So it's never going to be a number followed by negative infinity. It's never going to be positive infinity followed by a number. That cannot happen because we're reading it like we're reading a sentence in a book, left to right. Now, here are some examples of just the interval notation. So we want to write as an inequality involving x, and we need to graph it. So this is bracket or including 0 to 3, not including 3. Okay, so x is between 0 and 3, right? There's a parentheses around 3, so x is less than 3, but x is greater than or equal to 0. The equal to is because of the bracket. Okay. When I'm graphing it, I just take those two numbers if they are numbers. And then I also take those two symbols. So the 0 had a bracket, the 3 had a parentheses. Does that still make sense? X is greater than 0, or sorry, greater than or equal to 0. X is less than 3. X is greater than or equal to 0. X is less than 3. 0, 3. Yes, that works. Good. Here I just have the numbers 3 and 4, and it doesn't matter. You can, if you like graphing it first, you can graph it first. If you like putting it in, writing it as an inequality first, you can also do that. So 3 and 4, we had brackets. So I'm just going to graph what I see. I see 3 with a bracket, and I see 4 with a bracket. Remember, brackets mean equal to or including, okay? X is going to be bigger, right, than the first number and smaller than the second number. The equals are because of the brackets. And then x is between 3 and 4. So x is bigger than 3, smaller than 4. Which can also be x is greater than or equal to 3 and less than or equal to 4. Here, though, that we only have one number, right? We have 3, and then we have the term infinity. So, but I know 3 was first, so I can start at 3. If I'm starting at 3, that means I open the parentheses at 3, and it just goes on forever, right? So x is all the numbers bigger than 3 forever, but not including 3 because there was no bracket. Here we're at -5. From negative infinity to -5 and including -5. So I'm going to do a bracket. Negative infinity is the arrow to the left. So x is less than -5, right? But because there's a bracket, it's less than or equal to -5. All right, maybe now we're getting to solving. We solve inequalities the same way we solve expressions, except there's one rule. And that one rule is if you multiply or divide by a negative number, reverse the symbol so that the statement is true. Okay, just a quick example why we have to do this. If I had 2 is less than 3, yeah? And I said, I want to multiply this by -2. To keep it true, right? Ooh, first let's start with 4 equals 4, right? If I want to multiply this by -2 to keep the equality equal, to maintain the equality, to keep it true, I have to do the exact same thing on this side, right? 4 times -2 becomes -8 is -8. That checks out, right? However, if it's instead of an equal sign, it's an inequality sign, we still want, this is still true, right? 2 is still less than 3, but to maintain inequality, we have to do the same thing to both sides, and if it's negative, we have to flip the sign. Why? Because watch. 2 times -2 becomes -4, less than 3 times -2 is -6. It's no longer true. It's only true if every time you multiply or divide by a negative, you flip the sign. Okay, so instead of 2 is less than 3, we have -4 is greater than -6. We flipped the sign. That is why, okay? But it's okay if these are negative. So -1 is greater than, and -1 is greater than -2. Let's keep it simple. Is that true? Just to make sure. I'm going to multiply by 3. Notice that these are negative, but the one I'm multiplying by is not negative. -1 times 3 is -3. -2 times 3 is -6. This is still true. Okay, so you only flip the sign if the one you're actually doing, not the one you're doing it to, but the one you're doing it with is negative. Change the sign. Good? It's okay if these were always negative and you're not multiplying by a negative. You're multiplying a negative by a positive. That's okay. Don't change anything. If you're multiplying by a negative or dividing by a negative, change the sign. Right? So it's just like solving, except when you multiply or divide by negative, flip the inequality symbol. The first one, 3x is less than 12. Divide both sides by 3. X is less than 4. Good? Here's 4. Here's x is less than 4. That's from negative infinity to 4. Our next one was negative 5x is less than negative 10. Divide by negative 5, divide by negative 5. Remember, now, because these are negative, that sign must be flipped. Those cancel. I just have x is greater than a negative divided by a negative is a positive 2. Good. Here's 2. X is greater than 2, not equal to 2. X is greater than 2. So it's going to look like that. So my interval notation will be from 2 to until 2 to infinity, 2 until infinity. Here we have x over negative 2 is greater than 6, which is the same as x divided by negative 2, right? X divided by negative 2 is greater than 6. To undo divided by negative 2, I need to multiply by negative 2, right? So that those cancel. I just have x. 6 times negative 2 is a negative 12. And because it was oops, sorry, not that one. Because that one was a negative 2, I need to take that sign and flip it. So x is less than negative 12. Here's negative 12. It's everything less than negative 12. No equal to. Good. Reading it left to right, the first thing I encounter is an arrow pointing towards negative infinity, and then it ends at negative 12 with parentheses. Negative x is greater than 7. I can't just graph this. I want to graph x, the value of x, as an inequality. So I need to divide by negative 1, because dividing by negative 1 just causes the sign of that number to change, right? Anything divided by 1 is itself, but a negative divided by a negative makes that x a positive. Positive divided by a negative makes that 7 a negative, and then dividing by a negative number changes the sign. So negative x is greater than 7, and x is less than negative 7. Here's negative 7. We said x is less than negative 7. So if I was looking at that as interval notation, sorry, just mind blank, completely blank. Negative infinity to negative 7. Example 4, we have 5 minus 4x is less than 9. So even though this is a minus 4x, that doesn't mean we're subtracting 5, right? The 5 is still positive. So to get x alone, we're going to subtract 5 from both sides. And it becomes negative 4x is less than 4. To get x alone, we're going to divide by a negative 4 on both sides. Because that's negative, we flip that sign. X is greater than 4 divided by negative 4 is a negative 1. Here's negative 1. We're saying x is greater than negative 1, right? The way I would write that with interval notation, I'm just reading the number line from left to right. So I start with parentheses at negative 1. and I go towards positive infinity, so it will look like that. Our next one is 2x minus 2 is greater than or equal to 3 plus x. Now I want to combine like terms, but they are each on separate sides of the inequality sign, so I just need to move the x. So I'll subtract x. 2x minus x is just x. Good. Then I will move the 2 by adding 2 to both sides. X is greater than or equal to 5. Here's 5, and we're saying it's greater than or equal to, because of that equal to, it's going to be a bracket. Good. 5 to positive infinity. All right. The next one is 4 is less than 2x plus 2, and 2x plus 2 is less than 10. So we've been doing them all at once, all at the same time, like there are 3 sides instead of 2, but you can also solve them as 2 separate things. So you can call this 4 is less than 2x plus 2, and 2x plus 2 is less than 10, and you'll get the same answer. If you like just not having 3 sides of something. While we do have 3 sides, we just do every step we're doing to the middle to get x alone to all 3 of the sides. So here x is being added to 2, so we're going to subtract 2 from all the sides. 4 minus 2 is 2. 2x plus 2 minus 2 is just 2x. And then 10 minus 2 is 8. Good. Now, 2 is being multiplied by x. The opposite of multiplication is division. So we're going to divide by 2 on all 3 sides. 2 divided by 2 is 1. That leaves us with x in the middle, and then 8 divided by 2 on the other side is 4. Good. So I have x is greater than 1 and x is less than 4. X is greater than 1, x is less than 4. So our interval notation would be just what I graphed, parentheses 1, 4, close the parentheses. Again, if you wanted to solve it individually, you could just say 4 is less than 2x plus 2. So I'll subtract 2. It becomes 2 is less than 2x. Divide by 2. 1 is less than x, which I flip around to say x is greater than 1, right? Here, subtract 2. 2x is less than 8. Divide by 2. X is less than 4. So same thing if you wanted to separate it out. The last example was 1 is less than or equal to the quantity 2 minus x over 2, which is less than or equal to 4. Good? All right. Here, everything that's happening to x, we need to undo and do it and make sure we undo it in all 3 sides, 3 parts. So most importantly, this entire quantity is being divided by 2. So if I want to get rid of being divided by 2, just like I would get rid of any other fraction, I want to multiply everything by that denominator. So I'm going to have 2 times 1. 2 times 2 minus x over 2. Sorry. 2 times 4. Because of that 2, I multiplied this by 2, multiplied this by 2, and multiplied this by 2. 2 times 1 is just 2. The reason we did this was to cancel these. So now that's just 2 minus x over 1, or just 2 minus x. And then 2 times 4 is 8. Good. So we got rid of that 2 by that 2 in the denominator by multiplying all 3 parts by 2. Now I have 2 is less than or equal to 2 minus x, which is less than or equal to 8. That is a positive 2, so I need to subtract 2 to get rid of it. 2 minus 2 is 0. That doesn't mean that you've done something wrong or that you have to stop, okay? Make sure you keep the negative with the x. It's a negative x. 8 minus 2 is 6. You can keep working. 0 is a number, right? Just keep treating it like you would treat any other number. I can't use negative x, so I need to divide by negative 1. Anything I do to the middle, I should do to both sides. Good. Negative x divided by negative 1 gives me a regular x, but because I am dividing by a negative, I need to change both of those signs. 0 divided by negative 1 is still 0, okay? 0 divided by negative 1 is 0. Negative 1 divided by 0 is when you get an error, okay? So don't worry about continuing to work with 0. 6 divided by negative 1 is a negative 6 because positive divided by negative is a negative. Good? All right, we had to flip the sign, so it's very important. When you're graphing it, don't just go 0, negative 6, right? That's not true to the number line. On the number line, negative 6 is to this side of 0, right? That's why it's also kind of helpful to switch this so that the x is always on the left. So x is greater than or equal to negative 6, and x is less than or equal to 0. Or you can flip the whole thing around. I know negative 6 is actually less than 0, so I want to flip the whole equation and say negative 6 is less than or equal to x, which is less than or equal to 0. So just make sure when you're graphing it and when you're using interval notation that you keep these terms in order, okay? Don't put 0 here and put negative 6 here. Definitely don't say 0, negative 6, okay? These must go in order according to the number line. The number line must stay in number line order. Negative 6 always has to be to the left of 0. Good? No. No. Good? So it is still true that 0 is greater than or equal to x and x is greater than or equal to negative 6, but it's much easier to read it if you flip it around. Here's negative 6. Here's 0. X is greater than or equal to negative 6, less than or equal to 0. Good? Okay. Any questions? All right, here's one example I want to work on since we have a few minutes. So this will be on my math lab, on your My Math Lab homework. What do you do when you have 0 is less than 3 over x, which is less than 8 over 9? You have two fractions, you want to get rid of both the fractions, right? How do you get rid of a fraction? You multiply it by the denominator of the fraction, right? If I multiply everything by 9, this 9 in the denominator will go away. If I multiply everything by x, this x in the denominator will go away. So if I just multiply everything if I multiply everything by 9x, because it is the greatest or the least common factor of 9 and x, I should be able to get rid of both of my both of my denominators. Does that make sense? So this x will get rid of this x. This 9 will get rid of this 9. 9x times 0 is still just 0. The signs don't change. 9x times 3 is 27x. 9x times 8 is 79. Sorry, over x. 79x over 9. All right. Now these cancel, and I just have 0 is greater than 27. It's greater than 79. 72, right? Sorry. Oh, bad math. 72x. 9 times 8 is 72. 72x divided by 9. I can simplify 72 divided by 9, right? That was just to cancel that. Is 8x. Good. Any questions about how I did that except for the, sorry about that. So to get rid of those denominators, I found something to multiply to cancel them out. The x canceled the x, 9 times 3 is 27. The 9 canceled the 9, 8 times x is 8x. Good. So I have 0 is less than 27 is less than 8x. I can now, is this true? Is 0 less than 27? Yes. I can now just ignore this part. This part can fall off. It does not matter because it does not include the x, okay? Now, all I need to do, divide by 8, divide by 8. X is greater than 27/8. Okay. There was one more. Hold on. All right, number 26. Number 26 said, find the domain of this. All right. That means when you hear domain, you need to think, I cannot have, sorry, this is number 26, just to add some context of our homework. Cannot have a negative under the square root symbol, right? So the domain of this expression is that everything under here must be greater than or equal to 0. That's what they're asking. Okay. If they want to talk about the domain, they're saying it cannot be negative. So how do you write an inequality to represent the fact that it cannot be negative? It must be greater than or equal to 0. Okay. The last one, because I know we only have 3 minutes left, so I think you can do it from there, right? It's just a matter of interpreting it. Number 20 was x over 10 is greater than or equal to 1 minus x over 20. I'll let you look at it, sorry. Good. So what can we do here? Think about what we did over here. We had x in the denominator and we had 9 in the denominator. Now we have 10 and 20 in the denominator. Here we multiplied everything by 9x. Here we can multiply everything by 20. Because that will get rid of our denominators. 20x over 10, 20 minus 20x over 20. That simplifies to 2x, right? Because 20 divided by 10 is 2. So that, remember, is what you do if you see a fraction.